Hello, everyone. I am here with another speaker from YAL in Sydney, Australia, Jennifer Marsman.
Hello.
Thanks for coming on. Jennifer is a principal software development engineer at Microsoft. And she did an absolutely incredible talk about, well, you should describe it. It's amazing. Machine learning and putting something on your husband, right? Well, we'll get into that. But you're in the top 100 people in machine learning and artificial intelligence?
According to Analytica. Yeah.
That's very exciting.
Yeah.
Very exciting. Can you tell us briefly about your talk? What was it
Yes.
called? What did you do?
Yes. So my talk was called Using EEG and Machine Learning to Perform Lie Detection. And it started as just kind of a fun side project that I was working on, where I have a headset that's made by a company called Emotive. And I took this headset and it reads EEG, or your brain waves. And so I took the headset and I put it on my husband and I asked him a bunch of questions. And first I had him tell me the truth, and then I made him lie to me. And what that gave me is a labeled data set of what his brain waves look like when he's telling the truth and what they look like when he's lying. So then you can feed that into a machine learning algorithm and build a classifier to do lie detection. So
Are you making a product out of this?
I'm not, yeah. That would be funny. I work for Microsoft, so like Microsoft Enterprise Lie Detection 2.0.
Honey,
No.
do I look fat in these jeans would be a whole different thing, right?
Yes.
That would be, yes. Well,
But it was it's been a really fun like side project to work on, and I really enjoyed just all of the kind of like learning I've gotten out of it just by kind of choosing something randomly, like, oh, I wonder if I could do this, and then doing it. And that's a lot of, and then you just iterate rapidly, almost like Agile.
right. Experimenting, learning rapidly. And you
Yes.
you showed a video during your talk of you interviewing your boss.
I did, yes.
Can you say that? And you asked a very important question.
Yes, I did. I asked a couple. So first, I asked him just some easy questions to get the answer to get a baseline, essentially, to get data to train a model with. So I asked him just some very basic information, like, do you have brown eyes? You know, how have you ever worked for Microsoft? Things like that. And then I used those to train a baseline. I had him tell the truth for some and lie for others. And so I could use that to build a baseline classifier that was specific to my manager. And then I asked him two more questions, which were, is Microsoft the best company in the world to work for? And am I going to get a promotion? Because I really wanted to know the answer to that one.
Oh, wow.
And he said yes, that I was, but it was so funny. The really funny thing about that, Josh, was that I did not plan that in advance. Like, my manager, there happened to be a cameraman because we had we had to produce a number of videos that year. So our marketing team had hired a cameraman to like come to this team event that we were doing. And I just thought, oh, it'd be fun. And so I got my manager and the cameraman and just happened to catch it on video, but he didn't know that was coming.
So you put it, so he's just like, yes, you're going to get a promotion.
Yeah. So there was this really awkward little pause, which was the hilarious part. And so I'm so glad I got it on camera just because it was so very funny, because he was like, and then he was like, yes, you are. But I didn't know what that meant. You know, did it mean that he was lying? Or did it mean that he was telling the truth? And so
You ran it through
I just ran it through the algorithm, and the algorithm said yes with about 80% confidence that it was true, and I did get the promotion.
Oh,
so
that's such a awesome story.
It was fun.
So you're a machine learning person. You have been doing this a long time. You got a degree in this too, right?
I do, yeah, a master's degree. It's funny, my husband has a PhD, and a lot of my friends have a PhD, and I'm like the Howard Wolowitz of my group of friends. If you watch The Big Bang Theory, there's this one guy they're always making fun of because he only has a master's degree.
Oh,
That's me. I'm only the master's degree.
That's very cool.
Yeah, yeah.
Well, so experimenting and learning rapidly so you're constantly. How does that work with machine learning? How do you experiment and learn rapidly?
So machine learning, it's so funny that I think our passions have such intersections, because experimenting and learning rapidly is a huge part of machine learning. So some of the stuff I've done is around supervised machine learning, and supervised machine learning is the subset of machine learning that you can use to make predictions. So basically you take a labeled data set and then you can apply crazy beautiful math to it to be able to make predictions. So for example, what I mean by a labeled data set is if you want to be able to predict the cost of a home, for example, you would take a whole bunch of data. You take a whole bunch of costs of actual homes, and then also grab various features. So the cost of the home, the thing that we're trying to predict, is called our label. And then all the things that would affect the cost of the home are called features. So there might be a number of things like, the number of bedrooms, number of bathrooms, the number of years since the kitchen's been remodeled, square footage, the location, because I know I live in the Detroit area and you live in the San Francisco area, right? So those are kind of like the two, like maximum and minimum, and then kind of like normal housing prices are in the middle. Yeah, exactly. So you can take all that data then. If I have all of these things that would affect the price of a home, what I can do is apply a machine learning algorithm, and then it basically finds the correlations between those features and that label. And so it could be something as simple as a linear regression. It's different kinds of math depending on what kind of algorithm you use. It could be something as simple as like a linear regression type thing, which you can picture. That's a lot of math that people can understand a little easier. But ax plus by plus cz, if you remember that from college, just a weight times something. So if I had a whole bunch of number values, like the number of bedrooms, number of bathrooms, like that sort of thing, if it was all numerical data, you could maybe just apply weights times each of those and get be able to pull out a price based on that. So that's the very simple easy case when it's linear data. But there's other ways to do it too that are more advanced that can account for nonlinear data.
And do you are there like machine learning algorithms like this, these mathematical algorithms obviously, are they just in a catalog that you just like unleash on the data? Or
so there's a number of different libraries that are well-known libraries that people use. There's libraries in Python. There's tools like Microsoft has a bunch of tools like Azure Machine Learning that contains 25 algorithms inside it already. So there's a lot of different well-known ways to do it, but they're all based on different things. And it's really funny because what's in tends to fall in and out of favor right now.
It's like fashion.
Yeah, it's like fashion, right? So when I was in college, it was like genetic algorithms were all the rage, which had some random mutations over time, and that was considered really good because it was how life model, and that was the big thing then. And then there's other things that have come in and out. Decision trees were could model nonlinear data really well, and that was using information game theory, and that's really cool too. And then right now the pretty girl in the room is deep learning, and that's using deep learning. Yeah, so it's using neural nets with a lot of hidden layers, very deep hidden layers with a lot of layers in the middle to be able to make predictions. And that's deep learning is essentially what solved problems like automatic machine translation between languages and speech recognition and these other kind of big things that you can now see, are essentially, it's funny because when I went to college back, 15 years ago, those were considered artificial intelligence, being able to detect the emotion on someone's face, that sort of thing. And now it's essentially just a solved problem. We can do that. We can detect faces and images. We can do a lot of these things.
It's remarkable.
Yeah, deep learning has unlocked a lot of that.
And so, so when you say experiment learn rapidly on a data set, are you just trying different models?
There's a couple different things. Great question. So first of all, I can iterate sometimes not even on an algorithm, which algorithm works best. If someone just hands me a bunch of data and says, "Here, Jen, go do something with that." Is it linear? You could see if it's linear. Is there a nice easy linear correlation between the data and the thing I'm trying to predict? If it is, bam, easy thing. If you want to do so, if it's not linear, a lot of things where when you think about predicting illness, which is a very wonderful altruistic way to use technology and machine learning, you'll find that a lot of times in a lot of illnesses there's a situation where children, infants, are very susceptible to a disease and more likely to pass away if they contract it. And then healthy adults tend to be okay, but then the elderly tend to be more likely to also pass away if contracting it, that sort of thing. So the risk is high for the very young and the very old, and in the middle it's a little bit okay. And so if you have a curve that looks like this, and if you're trying to predict age versus likelihood of dying, you're never going to be able to fit a straight line to that, right? Because it's a curve, it's quadratic, right? Exactly, it's not linear. So you need to get into a higher order polynomial math in order to do something like that.
Wow.
But it's really neat. So you might experiment to learn around what kind of algorithm works best based on the shape of your data. And then once you land on an algorithm, there's a whole bunch of initial parameters. If I'm doing a decision tree, for example, you would have to set what's the width of the tree and the depth of the tree, how many layers do you want to build to, and those kind of things. So tweaking those little initial parameters also make a difference in what kind of accuracy you can get just based on what kind of data you're working with. So there's a
Wow.
lot of
Really
art
cool.
to it where you try
Yeah.
something, see how well it works, look at accuracy and precision and recall numbers, and then iterate and keep going until you can build the best mathematical model for what you're trying to predict.
That's awesome. That's
Yeah,
really awesome.
yeah.
And you briefly mentioned a story of someone related to his vision, seeing.
Yes, the Seeing AI project is one of these things that tugs at my heartstrings. It's one of those things. So we actually have an amazing gentleman that works at Microsoft by the name of Saqib Sheikh. And he works out of our, it's either Cambridge or London, but somewhere in the UK. He works out of our UK office, and he's blind. He tragically lost his sight at the age of 7, I believe. And what he is working on now is essentially a way he's using Microsoft's cognitive services to help fix that essentially.
Wow.
So he's using so there's 2 different ways. He has a mobile app version of it, and then he also has a pair of glasses. So there's hardware he can do as well. So if he hears something really strange, like you hear a weird noise or something, he can actually swipe the side of the glasses or use the mobile app to take a picture. So the glasses will actually take a photo of whatever is happening in front of him,
Sure.
or the mobile app, and then that's sent to the cloud and processed using some of our pre-trained computer vision algorithms. And then it comes back with a little description of here's what it is. And so he hears something like, oh, it's a boy riding on a skateboard. And you're like, oh, that's what that noise was. And so it's this amazing thing where he can actually use computer vision to help him in his everyday life.
Also, he's getting a little movie with sound as well.
Yeah, so it actually talks out loud to him. Yes, so it's using speech to text. Text to speech to vocalize that to him so that he can hear it.
But I mean, he's not taking a photo of the person on the skateboard. He's getting a little movie of the person on the skateboard to hear.
No, oh, good question. So the question is if it an image or a video? It's actually an image. So it takes one flat, But
he's got the sound too.
Yeah, well, he can hear a sound. He doesn't know what it is, and so taking the picture, sending it up, and then be able to process. Okay, this picture is of a guy riding a skateboard, and they're like, oh, that's what that noise was.
Okay,
just so you can recognize it.
That's
and
incredible.
There's other things that it does too. It's really cool. It also does emotion detection. So basically, imagine I don't know if do you do webcasts as well or webcasts, live webcasts?
Sure, I've done them. I just did one when I was in Melbourne for a bank, and I couldn't see anybody.
Wonderful.
I was talking, and I was like, I can't see their faces.
Exactly. So I've done that as well, where you're doing a webcast, and we're doing one right now, and we have no idea how people are reacting. Are they interested? Are they falling asleep? That sort of thing. And that's Saqib's life, every day. Sure. He can never see and get those visual cues of how people are he's explaining an idea. Are people going, Are people going, oh, love it? He doesn't know. Yeah. And so another thing that it does is emotion detection. So you can do a little swipe and it will actually say, there's a, it'll try to guesstimate age and gender. So there's a 25-year-old woman looking surprised, or there's a 40-year-old man looking disgusted, or those kind of things to actually tell and give him that feedback on emotions and what people are thinking.
That's fantastic.
It is. And then the final thing is OCR. There's optical character recognition as well. And so what that means is actually being able, if you have a digital image of words, being able to translate that into actual text. So the idea of if he sits down in a restaurant and there's he needs to read the menu, right? You can. It's hard to. You can ask a waitress or someone to read the menu to you, but that's it's probably a little embarrassing or whatever. But he can put it down, and it's actually using some neat edge detection logic to figure out to kind of see the edge of the menu from the table surface, and then he can actually say, read me the menu or read me the headings, and then it can tell him, there's salads and pasta and pizzas and blah blah blah, and
unbelievable.
It really is. So it's an amazing example of making people awesome and being able to really take that kind of use machine learning and technology. Right there, we're right there, making people awesome. But I love that.
That is incredible. I mean, I could see people, lots of people using this technology.
Yes.
Not just people with visual impairments, but just people just can't even see the menu. But it's incredible. So it's using machine learning in the cloud, bringing back voice technology to communicate with you. It's just, this is the future.
It is. It's really amazing. And those are the things that make me most excited, is when we can use technology and machine learning to make people awesome, is this just most fulfilling
it's
thing.
Incredible. Yeah, that's what makes the magic of this happen.
Yeah.
And you work at Microsoft. You've been at Microsoft for a while then, haven't you?
15 years. Yeah,
wow.
It's 15 years this year. year.
That's fantastic.
I'm quite the old lady now. Yep.
So, and you've seen different CEOs since was it Bill Gates when you first started, or?
Yeah, actually, gosh, I'm trying to think
was that
way
Ballmer,
back there.
Steve Ballmer?
I've definitely lived under Ballmer for a long time.
Yeah.
It might have even been Gates at the beginning, but honestly, I don't even remember when they transitioned.
Mm-hmm.
But yes, I've worked under both of them, and then now Satya
Mm-hmm.
Nadella.
Mm-hmm.
Yes.
How was that? How's he?
Honestly, I think there's been some reports in like the mainstream media about just like how different the Microsoft culture is under Satya. And I can confirm that is absolutely true.
It seems like really going in the right direction.
It is a different world. It is a different world. So I'm a huge Satya fan. I think he's a wonderful guy. And what I love about him is that he's so big about meeting people where they are. So I feel like in some prior days, we may have been like, everybody get on Windows, everybody come to us, everybody get on .NET. Like it was kind of like everybody come to where we are and come do this. And now it's so much more going out to people and meeting them wherever they are. So we're contributing to open source. We open source .NET. Like we took some of the stuff that we did and open sourced it, and then we're contributing to existing open source as well. There's actually a really neat story. In the Hadoop ecosystem, if you do any like big data work, there was this challenge to make Hive queries. So Hive, can query against Hadoop and HBase clusters and such. And there was a challenge to make it run like 100 times faster. And so Microsoft actually contributed to this work where there were like a bunch of folks like PhDs on the SQL Server team who just know insane amounts about query optimization because they have, PhDs in database theory and all this stuff, amazingly smart people. And they were working on this. So basically there were like PhDs on SQL Server. So like, which is $1 billion business, who are like giving away intellectual property into this open source thing. And like, that is a different world. That really never would have happened like 15 years ago. So
that's phenomenal.
It's so exciting to be a part of it. I am encouraged to, contribute stuff to open source. I think we're trying to be like, okay, here's the hybrid scenario. If people are using us along with some of our competitors, let's make them work well together. And Satya is really big on the whole growth mindset movement.
Oh, yes. Carol Dweck, right?
Yeah, so he published a book on it too as well.
Oh.
But like or Satya just did his was not the growth mindset. It was an earlier concept than Satya, of course. Yeah. But his book is kind of around that. It's called Hit Refresh. But it's really the growth mindset where you should be trying new things. You should be failing. You should be learning. And that's the way that we learn is when you grow. And so it's really easy if you are in a job and you're good at it and to just kind of coast and keep being good at it, but you're not really learning or changing or growing. And so that idea of growth mindset is that everyone in Microsoft is encouraged to like just go and do stuff outside of your comfort zone, try new things.
Oh my gosh.
And it's been a really big movement inside of the company lately, which is just phenomenal.
So it's safe to fail there.
It is. It is safe to fail. I mean, they let some crazy girl, who didn't have a neuroscience degree say, hey, I think I could do this thing with machine learning and brainwaves. Is it okay if I get a headset and do that? And they were like, sure, like, go ahead, do this thing, do this crazy thing. And so, yes, I absolutely had to have a safe place to fail because I was not sure that was going to work. It was just something I wanted to try.
Yeah, and putting Unix into Windows, I mean, that's also just a gigantic change.
Yes.
I mean, this is a real change.
It is incredibly real change. So the whole bash on Windows thing is amazing to see that kind of thing working and Linux subsystems, and it really is it really is a different place at Microsoft.
Yeah,
for sure.
And he's a software engineer, and
he is. He is.
Kind of helps to have a software engineer running a technology company, right?
I like working for engineers. I will say that. Yes.
Very cool. Well, Jennifer, thank you so much for stopping
thank you
by.
For having me.
Loved your talk, and hope others can see it or watch the video on the Yao channel. I'm sure your husband was happy to be the guinea pig on that. It's really cool stuff. Machine learning is just, I envy all that you've been doing. I mean, this is the future, AI and machine learning. I mean, this is where we're going.
It's a lot of fun.
And so everyone needs to learn this stuff. Where would someone who's new to machine learning go to learn this?
Oh my goodness. Okay, great question. Here's a couple of different answers. So Microsoft has a data science certification, so you can go check that out. There's resources online. I think if you just go to microsoft.com/AI, like you can, or maybe it's news.microsoft.com/AI, but there's a lot of great stuff there. there, and our machine learning team has a blog and stuff like that. I have a blog, and I'm on Twitter, and I try to release great machine learning related content on a regular basis. And then, if outside of Microsoft resources, there's some really great online courses that exist around machine learning. So the really popular one that a lot of people know about is Coursera, which is taught by Andrew Ng, who is machine learning. He was a machine learning professor at Stanford, and he's just really good. Like, he does a great job just breaking down kind of, here's what gradient descent means, and here's this, and just kind of a lot of the basics of the math and such. So like the Coursera online course is, great thing to take, and it's free. And then he's since moved on and done another thing. Deeplearning.ai is his latest project. So if you want to jump right into deep learning, you could check out deeplearning.ai, and there's courses there as well.
Just review your math beforehand, right?
Yes,
you need to know calculus or something, or
you need to know some math, but that's the thing, is I think he does a really good job of teaching most of the math in the courses. So some of it's like, I remember this from, maybe you'll have to refresh or think back to, stretch your mind and think back to like middle school or high school math a little bit. But I don't think any of it is, it's not undoable. And so there's a lot of great resources like that online. I think MIT also published on YouTube a series of machine learning courses. So there's a lot of great stuff out there if you look for content like on YouTube and such.
Awesome. Well, thank you so much again for stopping by. I think it's time to go down to the conference and get some drinks.
Yes, it is.
Thanks again, and we'll see you.